All right, young scholars. Over the next 2 weeks, we are going to focus on some introductory information related to databases. You'll notice below, in addition to our PowerPoint for this week, there are a great deal of links provided. These are specific lectures I've given in my Management Information Systems course at Seton Hall University. You're more than welcome to look through them as you choose. I introduce databases, give some information. I provide some information on an uncommonly used database tool these days called Microsoft Access that comes with the other Microsoft products. And I even provide you with me giving a lecture on how to use a SQL compiler if you so choose to view them. So this week we'll cover databases. While we can use databases to store information on our computers, such as the aforementioned Microsoft Access, it is more common for us to store data online these days. Think about your Instagram login information. It's stored in a big database online on their servers, just like everyone else's. So there's three types of primary storage, as you see here. Main memory on the PC, cache memory assists in the speed of loading web pages. So the more you go to a specific web page, in theory, the quicker it's going to load. Flash memory is removable memory, such as your external hard drive, USB, etc. Secondary storage, we have three types here: magnetic disk, optical disk, and magnetic tape as reference. Additionally, we have what are called file systems, which help us organize data and help us retain those pieces of data even after we close a specific program. Essentially, what our operating system does for us helps us store the information we want to keep while constantly removing the information we do not want to keep. Types of secondary storage include hard drives, floppies, optical disks, flash memory, etc. If multiple computers are linked, you may be able to access over the network. Think of if you have a printer set up on your network, everybody can print to that specific printer. If your settings allow, where you're sharing your laptop, computer, desktop, whatever it may be, to another computer, they may be able to access files you have stored on your laptop. A file name, everybody should know, is the name you give to your file. It's then used as a reference piece to find where it is stored in your computer. Metadata, we've talked about this in Info 2105, is data about data. I've provided the example in the past about when I go to ESPN and right click to view page source, we get our page source where you'll notice a bunch of metadata, meta tags here. So we give our, in this instance, we're talking about Twitter. What is the Twitter site? What is our Twitter link? How do we get there? You could have image height set up, image width set up within the meta properties. So any specific image in this instance, it's claiming is going to be 1200 width, 630 height. And that is more than likely when they have these setups in the middle and constantly change them, they are set to those specific sizes. So utilities also exist on your computer. File systems use them to initialize, alter parameters of, and remove an instance or file within your file system. Think of a defrag tool. It helps in moving, changing files as you need them to. Providing access and permission is important, especially with databases, because it allows or permits other individuals other than yourself to edit, change, add to, delete specific files within that database. User data is another important purpose of the file system. One thing that people may not realize when they send files from one person to another, especially when it comes to academic honesty, is it shows who the initial person is who created that file, and it also shows the last person who edited it. So if you're not working in a group and you send a file to somebody and they go ahead and copy it, and it shows you created it and they're the last to edit it, it's not going to work out well, especially if your professor goes and looks at that. They may think that person Y cheated off of person X. Network file systems act as a client for a remote file access protocol. For example, you can upload a file into Blackboard, for instance. Then anybody who has permission to access it can pull it down from that specific web network. Logical files. In essence, you could see here the definitions of sequential access and direct access. The best way I express sequential access is that you have access to everything from A to B to C to Z. Whereas with direct access, you're only provided to access to what you need. So for example, sequential access, let's tie it to the course. I have access to the grades. I can add grades for everyone in the class. Whereas direct access, you have access to only your grades. You don't need to see your classmates' grades, just yours. So here on slide 13, we simply have a disk drive image. And this is how a disk drive looks as far as setting up files onto it is concerned. They have tracks, sectors, and blocks that attribute to where all the data is stored. Now this is perfectly set up. Green all together, blue all together, orange all together, purple all together. Unfortunately, that's not usually how it works. See here we have how the blocks are broken down into a track and sector 0, 0, 0, 1 to demonstrate where everything is stored. As mentioned, sometimes you'll have info here, this is empty, info here, and then you save something, it jams it in between the two. Or it uses the open space after that, depending on what is available and what is needed. That's where directories come into place. Where are we saving the file? What do we need? Say you have 5 classes you're taking this semester and you're doing assignments for all of them. You may save your files, create different directories for them. Each class has its own directory where you send or save the files to. So when it comes to saving files based on contiguous allocation, you're going to just keep using free spaces as available. So we have file A here, file B here, file C here. Free space, we just put any new saved file here. But when we defrag, we can combine spaces so that we have more space available that's free to save new files. It's somewhat harder to retrieve a file if it's scattered about, so it's more common to run the fragment tool, have it set up overnight while you're sleeping to combine and create more space. So if you had file E here saved based on this example, it jammed part of it here, part of it here, part of it here, part of it here. A little harder to retrieve it, as opposed to if you can defrag and move file B here, file C here, file D here. Now you'll have empty space at the end to save it all next to each other. So there are three types of allocation. Contiguous, we try to put everything next to each other. Linked, we know where it is, but it may not necessarily be all together. Indexed, we know exactly where it is. We pull it from its specific location. Here's an example, again, of how the contiguous allocation works. We try to get everything next to each other as close as possible. In some instances, we may have to use different spaces. Linked allocation, as explained, everything is referenced to one another, even if it's in completely different sections. When everything's connected like that or linked, it's a little easier to retrieve than if it's just thrown about and saved in different sections. Indexes help us retrieve data. Think of a file cabinet. We retrieve data, from each drawer. So we have, as I mentioned, similar to the directories or folders. So here's an example of index files. But if the index can't fit in a block, it's going to be used in multiple blocks, which might make it a little harder to retrieve. You'll notice here, pieces of a file may be reorganized to fit next to each other. If you notice, we're pulling out some of the numbers down here to reorganize and set up so everything is now in order. In essence, the more powerful your computer, the quicker it is for files to be found and opened. But file seek time depends on the speed, etc., associated with your computer. Now, file transfer time may depend on computer speed as well as, in some instances, web connectivity. If you're going up onto the web to try and transfer a file, obviously the web connectivity will impact how quickly you can retrieve or transfer the file. There are different seek time algorithms that can be used in order to determine how quickly you might access your files. You also want to have some kind of direct access. Depending on where it is, people can randomly access different files on your computer. You want to know where they are. Where is this file? Do I need to encrypt it? Do I need to hide it from other people who may be using my computer? We talked about blocking earlier, where we save our information and our files. There are two common types of access methods: queued access and basic access. Queues are how we specifically search within databases. So we give a queue to a database. This is what we're looking for. This is what we're trying to find. The same applies to QE to access. With RAID, or redundant array of inexpensive disks, we're able to store data on multiple drives, but only use them as a connected tool. So you notice here disk 1, disk 2, disk N, basically any number of disks, we can retrieve the information from all of them. So databases for storage, they allow us to store tons of information in one specific organized space. You could have multiple databases on one web server. You may have experience using Microsoft Access in the past, but it's more common to use MySQL these days, which is an online database version. And databases, most importantly, allow us to retrieve information that has been stored. So you give permission to 8 other people, everybody now has the ability to access that information within that database.